Okay, so now we are on the last section for chapter 3. It's kind of a short chapter. So 3.4 is all about graphs of exponential functions. So exponential growth and decay. So before we saw the exponential growth and decay use functions of the four, f of x equals c to the ax, right? So an exponential function, or a shorthand function with an x, of base a is a function of the form where a is greater than 0 and does not equal 1. If it equals 1, it's a constant function. It has different properties. The domain is all real numbers. It's of the form f of x equals a to the x. Okay, so basically the constant is at 1 right now, and then we're going to expand it. All right, so graph by hand, f of x equals 2 to the x. So we are going to, I usually draw just one of the quadrants, but now we're going to draw all the sides. Let's call that 1, -2, -3, 1, 2, 3, 1, 2, 3. Oh, that was not even. 3, 4. Okay, cool. So I know when x is 0, it's going to be 1. Oh, here, choose orange. Okay, and then at 1, it's going to be 2, and at 2, it's going to be 4, and it's going to go up and up and up and up and up like that. All right, but what about on the other side? So now, if you're going to do this by hand, we can also make a little chart. So x, f of x. So at like 0, 1, 2, we know it's going to be 1, 2, 4, but at -1, it's going to be like 2 to the -1. Remember, negative exponents, I can make them happy exponents, positive exponents, by moving them to different parts of the fraction. So right now it's in the numerator. So if I move the 2 to the denominator, it'll be happy. So 2 to the -1 is going to be 1/2, and 2 to the -2 is going to be 1/2 squared, which is 1 over, oh, that looks too much like 4, 1/4. And then it would be like times 1/8 and so on. And it goes like that. So it keeps going on and off forever. It's never going to hit 0. It's just going to get really, really close because that denominator is getting really, really big while the numerator just stays 1. And basically isn't changing. All right. So now, so that was a fun way to do a graph and just make a little chart. Do like 5, do 2 negatives, 2 positives, and then the initial condition, and then you'll have a pretty good graph after that. Are you okay? So now we're going to graph by hand. F of x equals 3 to the x, and g to the x equals 1/3 to the x. So we'll do x, f of x, g of x. Make a chart first. We'll make this one pretty big. So then let's do a kind of similar thing. -2, -1, 0, 1, 2. So each one of them's initial condition is going to be something to the 0 power, which is always just 1. We don't have that c really our initial condition. So it's kind of like hidden there as 1. So 1 and 1, 3 to the 1, it's just 3. 3 squared is 9. 3 to the -1 is 1/3. And 3 to the -2 is 1/9. Okay. So 1/3 to the first power is just 1/3. And 1/3 squared is going to be like 1 squared over 3 squared, which is 1/9. That's one of your exponential properties that we talked about in the beginning of the class a few weeks ago. And then for the negative ones, I like to do the positive ones because they're really easy. 1/3 to the -1 is just going to be 3 to the 1. And then 1/3 to the -2 is going to be 3 squared, which is 9. So, see if I can grab this graph because I liked it. Paste. Okay. So Duke might bark in a second because there is some delivery man. 1, 2, 1, -2, -3, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's do f of x in orange. So at 0, it's going to be 1. At 1, it's going to be 1, 2, 3. At 2, it's going to be 9. And then at -1, it's going to be 1/3, 1/9, kind of just like approximating it. So then our graph is going to kind of look like this. Oh, good. Up and up and up, right? As long as it has the general idea and you're hitting your initial condition and maybe like one of your points exactly. Okay. If you're drawing your graph by hand, you can make the points look like they're on the right point. Okay, so now G is also going to be, G is going to be in maroon. So it's also at 0, 1, but then at 1, it's 1/3, and then 1/9. So this would get really small towards 0. And at -1, it would be 3. And at -2, it would be 9. So that's getting bigger this way. So, right, we always read graphs left to right. So g of x is a decreasing function, while f of x is a increasing function, or growth and decay. So, and they kind of mirror each other. So we can see the relationship of if a is a value versus 1/a being that base. So that's pretty cool. So how do the graphs change as a changes? So let me see. So none of you are there to say that. Say, don't want to be in blue. You're okay, bud. So when a is greater than 1, the function is increasing. Now you decide to eat dinner. When a is less than 1, the function decreases. And we know that from 3.1, talking about exponential growth versus decay. And we can really see it in that model right there. All right, so now let's talk about when we just vary a, they're all greater than 1, but now it's like 2, 3, and 4. Okay, so let's keep doing x, and then we'll do 2 to the x, 3 to the x, and 4 to the x. And we'll keep doing -2 to 2. And remember, that's just kind of get a good idea of what the graph looks like. You can do whatever numbers, but definitely do some negative values as well. And initial conditional. So, okay, so we're going to do -2, -1, 0, 1, and 2. So 2 to the -2 is going to be 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. So this would be 1/9. 1/3. Remember, multiply each one of them by 3. So that 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. 1/4 is 1/16. 1/4, 1, 4, and 16. So if I were to graph these with my varying options, so just draw this. Not as nice as I wanted to. Okay. Okay. So let's do 2 in orange. So I'm going to start at 1, 1/2, 1/4, and then 2, and then 4, it's right about there. Kind of like there, right? Make that dot a little bit bigger. Beautiful. Okay, let's do maroon for 3 of X. So again at 1, but then at 4, 5, 6, 7, 8. So this would be like 9 up here. But then 1/3, so then it's below, and then 1/9. Okay, and then we'll do like a fun green for 4. So again, we're gonna be at 1 and 1/4, and then 1/16. But then it's gonna be 4. Okay. Okay, so that's 4 to the X. Excuse you. 3 to the X, to the X. And 2 to the X. Okay, so the larger A is, the faster it grows, right? We can see that, right? 2 to the X is all the way down here, while 4 to the X is all off the charts already at X equals 2, which makes sense. If I would rather have my bank account triple, if not quadruple every month rather than double. So what happens to f of X if we throw in that initial condition of C? So right, we first just talked about A to the X, so we can focus on one thing, A. What happens to f of X equals C A to the X as C differs? So let's look. So we're going to graph C times 2 to the X when C equals 1, 2, and 3. So I'm actually going to grab this chart because I quite like it. Copy. Did you just throw up? Okay, no, don't like me. You're okay, bud. Okay, I don't want 4 to the X and I don't want 3 to the X anymore. You're okay. Because we already did 2 to the X, right? That's when it's like 1 times. Oh, that should be blue. Blue. And then we'll do like 2 times 2 to the X and 3 times 2 to the X. Let me also grab this while I'm over here. I only want the orange one though. Okay. So we already know that our orange one is 2 to the X. So let's do 2 times 2 to the X. So now my initial condition isn't going to be 1 anymore. It's going to be 2. And then each time I'm going to multiply by 2. So then it's going to be 4, and then it's going to be 8. No, yes. And then this is like 2 times each one of these values, basically. So 2 times 1/2 is going to be 1, and 2 times 1/4 is going to be 1/2. So basically, I'm just kind of like shifting it over, which is pretty cool. 3 times 2 to the x. So I know it's going to be 3 times, right? Because the 2 to the x is like this column right here. This is 2 to the x. So then I'm just multiplying everything that's in this second column by 3. So 2 times 3 is 6. 4 times 3 is 12. 1/2 times 3 is 3/2. And 3/4. Okay. So let's graph this first one, 2 to the x. So I'm going to start at 2 now, and then be at 1, and then be at 1/2. And then at 1, it's going to be at 4. And then at 2, it's going to be at 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's like over here. Up and up and up, and that is 2 times 2 to the x. And then for 3 times 2 to the x, I'm going to start at 3. Then it would be at -1, it would be 3/2. And then 3/4. Right? Yeah. And then at 1, it would be 6, 6, and then 12, which is off the charts. Okay. So now these things aren't overlapping at all like they did the first time. And they're kind of increasing a little similar, but not a lot of similar. Where's my orange? There it is. Okay, cool. As c increases, f of x is stretched vertically. So I'm kind of just going like, whoosh, like that. Okay. And I can tell what c is by looking right here at all of these things. And that helps me find c if I'm looking at just like some generic function, right? So now let's look at some generic functions. So these are actually in your textbook. So we're going to ask to find the function from the graphs. So C is going to be where it intersects the y-axis. That's usually my initial condition. Well, that always is my initial condition because that's when x is 0. So I want f of x equals c to the ax. Well, c is clearly this point right here, 1. So c equals 1. So now I know that f of x is going to equal a to the x. You're like, okay, so how do I find a now? I only have really one unknown. F of x and x are points y and x. I can just find a point and I'll be left with my one unknown, which is a. So I'm given the point -1, 1/5. So f of -1 is going to equal 1/5, which is like a to the -1. So basically, I'm going to, whoopsies, plug in -1, 1/5 into f of x equals a to the x. Okay. And solve. So a equals to the -1. There's lots of way to do this. So you can think of this as like, oh, 1/5, sorry, it keeps moving. 1/5 equals 1 over a. So I can multiply each side by a. So times a times a. So I have a over 5 equals a times a gives me 1. 2 over 2 is just 1. And then I need to get a alone, so I multiply each side by 5. So a equals 5. So that would tell me that f of x equals 5 to the x. How can I check that? Plug in -1, and you'd see that you'd get 5 to the -1, which is 1/5. Okay. You could have also from here done 1/5 to the -1 equals a to the -1. Kind of how we solve power equations to the -1, which would have given you a to the 5 immediately. Okay, so that's another way of doing it. Sorry for rushing this. I'm like very excited about it. Okay, give myself some space. So that is my function there. So this one, let's call this one g of x. So we're getting g of x, just because I want to, equals c a to the x. And then we're told this point right here is 3. So I'm told that c equals 3. So now I have that g of x equals 3 times a to the x. So now I'm going to plug in -2, 12 into g of x equals 3 a to the x. Okay. So that's going to tell me that 12 equals 3 times a to the -2. It'd be too easy if I didn't give you a negative exponent. So I'm going to divide each side by 3. Right, we're just solving for a right now. So 12 divided by 3 is 4, a to the -2. So I want a's power to be 1. So I need to raise each side by 1 over a's current exponent, because when they multiply, it'll give me 1. So this is gonna be 1 over -2, 1 over -2. So a is going to equal, just switching the sides, 4 to the -1/2, and I can keep solving for that. I can bring the negative in, so that's, actually, let's bring in the, no, let's do that, yeah. So that's going to equal 1 over 4, a negative exponent flips the fraction. One over 4 to the 1/2 is the same as saying like square root. And we can take the square root of each thing. I know I'm drawing this out. You probably are like, Mackenzie, it's just, I know it's 1/2, but why is it not -1/2? Because a can't be less than 0. Right, because remember, if I took the square root of 4, it'd be plus or minus 2. But since we've already said from the beginning of this chapter that a cannot be less than 1, then a cannot be less than 1. What am I saying? A cannot be less than 0, because if a was a negative value, I can't always take a negative square root of that. I can't take the even roots of negatives, and it'd be kind of crazy. If you ever look at a graph of one of those, it's not cute. Because a needs to be greater than 0. So a equals 1/2. I'm not done. I need to build my function. So that's going to be 3 1/2 to the x. And I know that a should be something less than 0 because this function is decreasing. So that makes sense. Okay. Oops. And that is a quick way to check yourself of like, knowing things about A. Okay, great. I think that's it. Yay. So we're done with chapter 3. Chapter 4 is my favorite chapter. And it's about exponential functions, brother function or sibling function. All right. So I will see you guys there tomorrow. We're doing like a fun interim function section first. So we're skipping the first part of 4 and going to the last section of 4. So that's why I'll see you guys next. All right. See you later.